Let's talk about functions and graphs. If you want to pause the computer just for a moment to read this, these are our objectives for this section. Let's move on. Now let's talk about a function. Function is correspondence between a first set called the domain and the second set called the range. And let me talk about what it is saying. It's just basically starting, we have an order pair, a set, x, comma, y, where my x is my domain, which is my independent variable, and y is my range, which is my dependent variable. Okay, so this is what this is telling us. We have a set of x and y in this function, and our x is our domains and our range is our y's. So it's important to know this and understand what it is. It makes it easier to solve. So now we want to determine whether each of the following correspondence is a function. So if it's a function, then we will not have a repeated x value, okay? And if you'll look here, it says that we have -6 and 6, they go to 36. Well, let's talk about it. If I say -6 times -6, yeah, that gives me 36. 6 times 6 gives me 36. That does make sense. These are things that we know, but it's just basically saying that I have this order pair of x is -6, y is 36, x is 6, and y is 36. So it's just telling us, a lot of times we look at this and we're going to, oh, it's a perfect square of that. Yeah, that's true. But in order for this to be a function, my x values cannot repeat. Okay, so I have a -6, 36, and a 6, 36. So this is a function. The same with this one here. 0 cannot have a negative or a positive value, correct? So they said that this is going to be the only solution that we would have, which makes sense. The definitions allows more than one member of the domain to correspond to the same member of the range. So this is saying what I basically said. We cannot have a repeated x, right? But the y values can repeat. Okay. Relation is a correspondence between the first set called the domain and the second set called the range, such that each member of the domain corresponds to at least one member of the range. So what we have here is a relationship between x, comma, y. Again, it's my domain, comma, my range. Also, whoops, that's a parenthesis. Also, I told you it's my independent and my dependent. Okay. So now we want to determine whether each of the following relations is a function and identify the domain and the range. So if I was to say, okay, what is the domains here? Well, the domains are my x values, right? And since we have a repeated x value, this is not a function. My ranges is the y values. So I would be able to list them. And whenever you list them, you don't list if it has a repeated value, you only list it once. Don't list it twice. As you see here, here's an example how they listed the domain. They only listed the 9 once. However, whenever you go to the graph and you plot it, you notice that the x value has a repeated value on it, and therefore this is not a function. And again, on the range, you do not repeat the value if they have the same value multiple times in these parentheses. So, but in this case, they didn't. So this is listing. Whenever you see it like this, they listed the values, okay? These are at these points. Determine whether each of the following relations is a function in this next set. So let's look at it. All my domains, if I was to list them, let's go pull them first, is -2, 5, 0, 4. So yeah, it's a function. So I'm going to say, yes, it's a function because there's no repeated x value. And I can list them, -2, -2, 5, 0, 4. Okay, so I'll list it. Now let's look at the range value. So it's already a function. We established that. Now we need to list our range. So our Y values range, we got a 5, so we wrote a 5 here. Got a 7, wrote the 7, 1, and -2. So there's nothing repeated in the Y range. And if it was, we just list that value once, okay? Let's look. Is this one a function? Well, let's look at it. And I like how they did this here. They're just saying that this -5 maps to 3, this 0 maps to 3, the 6 maps to 3. So whenever you go to the graph and you plot it, my Y value at 3 is somewhere right in here. I got a -5 for X, so we got a point here. I got a 0, 3, which is right here. And then I got a 6, 3, right? So now we got this function going on at these points right in here. I just draw a dotted line so you can see that it's okay for the Y value to be repeated as long as the X is not. And so, yes, this is a function. And then they listed it. You see here, when you list the values, you only list it once. And since it happened, every one of these order pairs happened at 3, we're only going to have one range listed. But it still acknowledges that all these map to it. Okay, so notations for functions. The inputs, members of the domain, are my X values. We just established that. The outputs are my Y values. So whenever we have a function, it could be f of X, it could be h of X, it could be g of X, it could be q of X, it could be w of X. All this is telling me is that this here is the name of the function. So it's f, this one's G, this one's H, okay? And it's building on X. So f of X is telling me that this outcome is going to equal Y. So whatever my function is, it's going to yield my Y value. So we're building on X that's going to yield out a Y value. So this says it reads f of X or f at X or the value of f at X. So there's multiple ways of reading it. As long as you understand it, you pick the method you want. So now it says a function is given f of X is equal to 2x squared minus X plus 3. So we're giving this function, and this function name is f, okay? And we're building on X, and whatever the outcome is, it's going to yield my Y value, okay? So if I plug in, so this first example, I plugged in 0 for X. Then I'm going to plug it in everywhere as I see X. And then I'm going to do my operations that are before me. So 0 squared is just 0. 2 times 0 is 0. Minus 0. So I got plus 3. So my order pair here would be 0, 3. And that's where I would plot it on the graph. 0, 3. Okay. Now they said, well, what if f of X is f of -7, meaning everywhere as I see X, I'm going to plug in -7. So now I have 2 times -7 squared, which is the same as saying -7 times -7. Negative times negative is positive. 7 times 7 is 49. And then I got negative times negative is positive. So next we're going to say, 2 times 49. So if we need to, we'll come over here, do our math. So 2 times 9 is 8, carry the 1. 2 times 4 is, oh, sorry, I said that wrong, guys. 2 times 9 is 18, carry the 1. 2 times 4 is 8, plus 1. So I get 98 plus 7 plus 3. And then when you add the 7 on, 8 plus 7 is 15, carry the 1. And then 9 plus 1, so I get 105. And then add the 3. And this is where they get the 108. So this order pair here is -7, 108. Okay. Now, there may be a time when they said, oh, what is X when my Y value is -2? Well, that would be a whole different ball game, and we're going to solve this pretty soon. So just keep in note that we'll get to this. Right now, we're just acknowledging what my f function is. We're plugging in for X, and we're solving for a Y. We get our order pair, and now we can plot it. All right. They said, oh, now what if my x is f of a? So everywhere I see x, I plugged in the f of a. So now I have 2 times, well, I have to square this 5a. So I'm going to distribute that square to everything inside there because 5 and a can't be put together. We don't know the value of a. Minus the 5a plus 3. Now I got 2 times. Well, 5 squared is the same as saying 5 times 5, which is 25. A squared minus that 5a plus 3. Now I need to distribute that 2 to everything inside that parentheses. So 2 times 25 is 50, and 2 times a squared is 2a squared. They did not distribute the 2 to the a square. Oh, my apologies. I overthought this one. Yeah, this happens. So if it happens to you, please don't feel bad. Just reevaluate it. Okay, so I just had to pause for a second. I did distribute the 2 when I distributed inside that parenthesis. So it is 2 times 25 a squared, which is 50 a squared minus that 5a plus 3. Now, in order to combine like terms in adding and subtraction, we have to look at the variable behind the coefficient. And if you notice, this first variable has a square on it, the second one has a first on it, and this 3 doesn't have a variable on it. So this means we cannot combine them because a squared is not the same as a to the first. And if you have no variable, then you can't combine it. So that is my final answer. This here is. Now let's look at when we plug in a minus 4 into x. So what do we got? I'm going to do this step here. It skipped this part right here. So I'm going to do this on the side right here. So I got a minus 4 squared. Please forgive me on my speech this morning. All right. That is the same as saying a minus 4 times a minus 4. So I'm going to use the distributive method, or you can use the full method. It's up to you. The full says we're going to take the first in each parentheses and multiply them together. So a times a. I'm going to go ahead and put a plus sign in between them. Now let's do this. Let's say, our outers. So I got a times negative 4. I'm going to use parentheses because that 4 has a negative sign on it. I'm going to go ahead and put a plus sign between them. And now my inners. Well, my inners is going to be this negative 4 times that a. So I'm going to put it in parentheses. And then I'm going to put my plus. And then we're going to do our last. So I got my last is negative 4 times negative 4. I'm going to use parentheses again because of that negative sign. All right. Now, whenever we multiply like bases, we add the powers. So if you notice, a to the first times a to the first, that's a raised to 1 plus 1, right? Which is a squared. Now I got a positive here times a positive times negative. So negative times positive is negative, and 4 times a. And I'm going to stop just for a second. Let's talk about this. If I have 2 times 3, we know that's 6. We know 3 times 2 is 6. So when you multiply, the order is not important as far as if I put the 4 before the a or the a before the 4, okay? So now over here on the next one, I got positive times that negative 4 times a positive. So negative times positive is negative. So I got 4a. And then I got positive, negative times negative. Well, negative times negative is positive. 4 times 4 is 16. Now let's look at it. We can combine any like terms. And I noticed that I have this negative 4a to the first. Negative 4a to the first. So the a's to the first are like terms. Let's put them together. This is like saying that I'm in the hole $4 and I borrow 4 more. So now I'm in the hole $8 and bring down the plus 16. Now we cannot put anything else together because there's no more like terms. So that is my final answer. Oh, excuse me. Guys, I got ahead of myself. I left off this last part. So all I did was in the parentheses. So that's my final answer for a minus 4 squared. Now we need to put this in parentheses and let's put on the rest of it. Y'all see there's a times 2 and there's this last part here. My apologies, guys. All right, so I'm going to bring my 2 down, and I got minus that a minus 4 plus that 3. So now we need to distribute this negative sign to everything inside this parentheses, and we need to distribute this 2 to everything in the parentheses. So now I'm going to go ahead and I'm going to erase the top part of this page so I can finish this. And if it'll let me, my eraser is not one to erase very good this morning. I'm going to clean this up. All right. So what I did is I finished this part right here. That's what we got over here. So now I need to take that 2 times that a squared minus 8a plus 16 minus my a minus 4 plus 3. Now let's finish this. So I said I'm going to distribute this 2. I'm going to distribute this negative sign. So 2 times a squared, we'll get 2a squared. 2, it's a positive 2 times that negative 8. So 2 times that negative 8, I'm going to go ahead and write it like that. Plus 2 times that 16. I'm doing an extra step. You do not have to. Negative times positive is negative. Negative times negative is positive. All right, we're almost done. So now I got 2a squared. Go ahead and bring it down. 2 times negative 2 times that positive 8. And actually it was the positive 2 times that negative 8, but I went ahead and just put it that way. That's going to give me a negative 16. Then I have a positive 2 times that positive 16 is 32. And then I'm going to bring the negative a down, but that 4 plus 3, I can put that together, right? They are like terms, this 4 plus 3. And that gives me 7. A positive 7. All right. So we're almost done. Oh, don't forget your a on that negative 8. Okay, don't forget that. And be careful with your notation. This a almost looks like a 9, so we got to be careful out there writing. Okay, the 2a squared still cannot be combined with anything, right? Because there's no variable with this square on it. So I am going to put together everything that has a to the first. I got this negative 16a minus this a, which means I'm in the hole $16 and I spend another $1. So I'm in the hole 17a. And then I got this positive 32 plus this positive 7. It's going to give me 32 plus 7 is 39. Let's look at their math here. Did I do, 16 times 2. Did I miss something there, guys? So let's look at that and see what we missed right quick, because they have a 64 here. Let's double check their math versus our math, okay? Because sometimes this happens. So I want to clean this back up, and I just want to try one more time before I say their math is incorrect. So anytime you get your answer wrong, just start fresh and new on another piece of paper, and do it on a separate paper and compare. So I just want to double check. So they said that we have this. Let's redo it. So that gives me a times a, which we said is a squared. A times that negative 4 is negative 4a. Negative 4 times that a is negative 4a. And then negative 4 times that negative 4 is a positive 16. So we put these together. Okay, looks great. They have a 32 here. Could be a typo. So when I did this, now I plugged in everything around it. And it happens. And then let's distribute the negative sign. So now I got negative a plus 4 plus 3. And then distribute the 2. So I got 2a squared minus 16a plus that 32, because 16 times 2 is 32. All right, so there is a typo on this PowerPoint. So our answer that we derived at right here, let me highlight it. I'm going to change it to, let's do blue. This one is the correct answer. There is a typo right here. So it's always good to double check. It happens, okay? It happens. And like I said, when you're doing your assignment, before you rule it out as, oh, my answer's right and theirs is wrong, like I said, get out now another piece of paper, write on the side, recalculate, compare. It's very possible you're correct, and it's very possible that you made a mistake. This is always good to double check. So whenever we're talking about graphing functions, we graph the functions the same way we graph the x comma y order. The only thing is our notation now is x comma f of x. Well, what did I say f of x equaled? It equaled my y value. So whatever I get out of this function, I'm going to get my y value, the second coordinate, my dependent variable. So that's all. That's just telling you. It's just a notation of explaining what we're working with. So on this first one here, we have x, or f of x is equal to x squared. So since we have a square on our variable, this means we're going to have a parabola. It's going to open upwards or downwards. And how I know what direction it opens is the positive versus negative value on my x. So if you look at it, your x here has a positive sign, which we don't write it whenever it's positive. That means it's going to open upwards. If it had a negative value on it, then we would have known that it opened downward. Now, what we're going to do is figure out where to plot it. Well, the first thing you could do is say, oh, let's look for the y-intercepts, which they created an XY table here. And I like how they did this last column where they did it as an order pair. Sometimes that's very helpful. So I like to say, well, I like to pick the values that are the easiest to pick first. So if I said if x is 0, then I know it's going to cross my y value somewheres. And look, it crossed it down here. Of course, it's not always on the belly of the parabola. It could be on an arm of it. But anyways, if I plug in 0 for my x value, right? If I plug in 0, then I get this, which is equal to this. And then that's that order pair here of 0, negative 5, and you plot it. And then next, okay, now we need to figure out where all the other values are. So it said, well, let's just pick negative 3. That's what they picked. I like negative 2, negative 1, 0, 1, 2. I like the small numbers. I mean, you could use whatever you want. But just remember in the homework, it should just be a 10 by 10 graph. So you wouldn't want to exceed it. So if I plug in negative 3, then I got x squared, and I'm going to plug in for x a negative 3. Well, this negative 3 squared is the same as saying negative 3 times negative 3. And I'm going to put these in parentheses on the inside of this. So negative 3 times negative 3. Negative times negative is positive. 3 times 3 is 9. And then I'm going to subtract the 5 from it, and I get 4 for my y value. So I get order pair of negative 3, 4. And you come over here where we see the, well, actually, I'm going to just walk you through. Let's start at the origin at 0, 0, which is this center place here. And let's move to the left 3 because x is negative. 1, 2, 3. So right here it is. And then from here, it says a positive 4. So let's go up the y values. 1, 2, 3, 4. And that's where they get this point. So this will take practice. I just encourage you to practice this one, compare the answers. If you have any questions, please reach out to me. And let's move. Let's see where my, there it is, my mouse. All right, now we have something other than, okay, so if my function had just x to the first, then that would have been a straight line. It's a linear equation. If it had a square, it's a parabola, right? But now we have a cube here. So this cube tells me we have a function that's gonna look like this, or it could look like this. Now, since this is a positive a value on that x cubed, then we know it looks like this. If it had a negative, it would look like this. And let me explain to you what it's saying, and something we're going to get into later for sure. If it has a positive value, then that means the graph is rising left to right, because remember, we read left to right. If it had a negative, so I'm going to put a plus on. If it had a negative value, it falls left to right. So maybe this will help you understand why the values the functions look different depending on the value on the leading coefficient. All right. So if you wanted to plot this, again, you can make an XY table. Again, I really like how they did the order pair value here. So if I plug in 0 for x, of course, we're getting 0 for y, because look, we just have an x cubed minus an x. So if I plug in 0, I'm just getting 0. If I plug in 1 or negative 1, then I'm going to have negative 1 times negative 1 times negative 1, all minus that negative 1. So negative times negative is positive, times a negative is negative. So that means we're multiplying the odd amount of times. If your power is odd, then that means I'm going to yield the negative. Then I got a negative times negative. Well, that gives me an outcome of 0 for y. So negative 0. So that's where we got our x-intercept. That was nice. If I plug in positive 1 and do the same, what happens? I get 0, and that's the other x value, the x-intercept. And then, of course, from there you would draw your graph with the arrows going up versus down. All right. Now, if I talk about a square root is an even root. So if it's a positive coefficient on that root, so positive coefficient here on that root, then it's going to open like this. If it was a negative, then it would go in this direction. Okay, so that's very helpful. And since it's a positive root, whatever I plug in here, it cannot yield a negative answer inside there. So this would work, right? Of course, it'd be a yucky plot on the graph. So I wanted to talk about how to find the domain of this right quick. And again, it's something we're going to get to. If we're looking for the domain of this, which will help you graph it, we take what's inside of it. And since it's an even root, we're going to take what's inside of it and set it greater than or equal to 0 and then solve. And then we get x is greater than or equal to -4, meaning that when I go plot this on the graph, that it's going to hit this -4, right? And x values are going to be greater than that. I can include that -4, comma, and it's going to go off to infinity. Now, that's what this bracket means. I can include it. How do I know I'm including it? Because I have this equal sign right here on my inequality. That's what that bar underneath it means. It equals it. So, and it goes off to infinity. However, you cannot put a bracket on infinity because you cannot stop infinity. It continuously goes on. So this means it's approaching it. That's what that parenthesis means. So whenever I go to graph this, this is what I get. I get -4, and it goes off to infinity, which makes sense. We'll go back to the one above us and talk about its domain here in just a minute. And again, the domain is my x values, and you read left to right. All right. And I wanted to show you how this is true. So if I plug in -4x for x, I get -4 plus 4, which is square root of 0. Square root of 0 is 0. just 0. So it's okay. But if I had -5 plus that 4, then that says that our answer is the square root of -1, which is imaginary. So no, we could not do that. That's why it's important to understand the domain. I want to go back up here to this one just for a second. Let's talk about its domain. So we look at this and we have a function, right? It doesn't have a fraction, so no fraction, no root. So the domain, since it's just a polynomial, that's what this is, it's going to be all real numbers. My drawing is not great, guys. This is also another notation for all real numbers. But this here tells me that it's going to include all values. And remember, parentheses goes on the infinity. So I got negative infinity right here. And if you look, it's true. Eventually, it's going to swallow up all the values of x. And then I got this positive infinity because of this arrow, right? It's going off and it's going to swallow up all the positive values. So this is this domain is all real numbers. The range would be the same way because look, it's going up and down. So the range would be all real numbers. On this one here, the range is not so. Remember, the range is the y values. That means we read bottom to top. So we start here. We start here at the bottom, and I'm going to go up, and what do I see? It hits right here. So I'm going to put a bracket because it's a closed parentheses. It doesn't have an arrow. It's stopped there. It doesn't have an open circle. So I'm going to put a bracket, and it's going to be 0 because that's what y value is. On the x-axis, y value is 0. Remember that. Now I'm going to follow it up. And what happens? It hits this here that has an arrow on it. Since it has the arrow on it, I know that it's continuously going off to infinity and it's going in the positive direction because you keep going up, it's positive infinity. So my range would be this, okay? All right, so now this here said it's taking this function. So I want you to practice and just plug in the x values and plot them and see what you get for y. And that's what this next example is. Now let's talk, or I can stop long enough for you to pause the computer. Practice this one. All right, now let's go to the vertical line test. The vertical line test is just determining if it is a function or not. So whenever we look at our graphs here, you look at this one here, it wants to know if I apply the vertical line test. What it does is we are going to draw a straight line because a vertical line is straight up and down. Of course, that's not a very accurate drawing. So we're going to determine if we get a repeated x value. So if you look on this particular function, and my apologies, my straight line is not a straight line. But a straight line, or it's also called the pencil test. If you have a piece of paper and it's drawn out on the paper, you'd lay your pencil on it. And if you have a value that's repeated for the x, then it's not a function. So this here passes the vertical line test. So it is a function. This one here is 2. Okay. So on this next one here, it says, well, is it applying the vertical line, is it a function? Well, if I go like this, I do not see my x repeating anywhere. So yes, this is a function. What about this one? No, it's not repeating here, but oh my, it repeated here, it repeated here, it repeated here. All it needs to do is repeat in one spot, and then we're going to say no. Same here. This one's not a function. It repeated in multiple places, but it just needs to be in one spot, and it's not a function, so that's not a function. So again, you can pause this and practice this. Finding the domains of the functions. All right, let's talk about it. You could pause that and read it. Remember earlier I said that if it was a fraction or an even root, then if it's not a fraction and not an even root, it's a polynomial, therefore it's all real numbers. There's also odd roots that would give us a different value as well. So let's talk about this one. This one is a fraction, and we got this here. Now they said plug in 1 for F and solve and see what you get. You could do that. If you're asked to plug in the X value, what do you get for the Y value, right? That's what it asks here. However, this also asks to determine the domain of this function. Whenever we have a fraction, guys, whenever you have a fraction, we're going to take whatever's in the denominator and we're going to set it not equal to 0, because one of the rules about fractions, the denominator cannot have a 0, cannot have an imaginary, cannot have a root of any kind. It can be odd or even. It cannot have it. It cannot have fractions in the denominator. It cannot have decimals in the denominator. However, we can apply some math to undo these issues, but we can't on the 0. So that's why we're going to set it not equal to 0 and solve. So I'm going to add the 3 to both sides. And now I get X cannot equal a positive 3. If it equals positive 3, then that means I got 3 minus 3 and it's 0. So therefore, it's not going to be it's not going to be a real number. Okay. It's going to be undefined. Anytime 0's in the denominator, it's always undefined. All right. So now when I write the notation, and it may be easier if I draw it on the graph, I'm going to put 0 here. I'm going to put 3 right here. I got positive infinity, negative infinity. And since we have a positive 3, that's why I went on this side. I'm going to plot it. And I'm going to draw my parenthesis out. It says all the way to here, all the way here. And whenever I put my circle on this 3, I'd actually put an open circle on that 3 because it cannot equal 3. And there we go. So I'm going to put an open circle there. So that means I'm going to have this look. This means negative infinity to 3 parentheses going to union 3 to positive infinity. This tells me all numbers from negative to 3 and all, or it could be or, it is or, all numbers 3 to infinity can be used. However, we cannot use 3 or we get an undefined function. So this is your domain. Okay. Now, if you didn't have an X value in the denominator, well then, and all it was a coefficient of 3, then we would, or a coefficient, a constant of 3, then we would be done. All right. So this, you want to pause it? This is just saying what I said. All right. Well, we got something else here. So we have a fraction, but we got a lot more going on here. In that denominator, I have x squared plus 2x minus 3. I'm going to do let's see. Let me do some notation here. Let's do the AC method. So AC says that we got this parabola or this quadratic that looks like this. And whatever our sign is on C tells us if we add or subtract. Whatever the sign is on B tells us what we use. Okay. So I'm going to take my A times my C that adds or subtracts to give me my B. So my A here is going to be 1, and my B here is a positive 2, and my C is a negative 3. So now I know I'm going to take my A times my C, which is 1 times that 3. Now I'm not talking about the negative sign yet, which gives me 3. That, now let's look at that sign on C that subtracts to get a positive 2, which is my B, right? Well, the product of 3 is just simply 1 times 3. So if I subtract it to get a positive 2, then that means the 1 needs to be negative and the 3 needs to be positive, right? So now I'm going to rewrite my quadratic. I got x squared. And remember, the b has a negative, or has an x on it, excuse me, has an x. So I'm going to take that x and multiply it to -1. So I got negative x. Plus that 3 times that x minus that 3. I'm going to split this in 2. Like this. And I want to factor each side separately. So on this first side, I got x squared minus x. I can factor out x. So x, if I pull x out of x squared, leaves me with only x. Minus, if I pull an x out of the x, means the x goes into itself 1 times, and I'm left with 1. Let's bring down the plus sign. And I see that I got 3x minus 3. That means I can factor out a 3. So 3 divided by 3x leaves me with x. 3 divided by -3 leaves me with 1, right? Because 3 goes into itself 1 time. And there we go. Let's come back and just write over it. My apologies. All right. So now let's look at it. I have this x times this parentheses plus this 3 times that parentheses. And if you notice, the parentheses are my common factors here. So let's factor out that parenthesis. So when I factor it out, we need to make sure and write it like I see it. So I got x minus 1. And when I factor it out, it leaves me with x plus 3. So check. This is where they get this part. Now, I'm going to take that x minus 1, set it equal to 0 and solve. Take that x plus 3, set it equal to 0 and solve. So I'll add 1 to both sides, gives me a positive 1. Because it was a -1, add it to both sides. Since 3 is positive here, I'm going to subtract it from both sides, so I get a -3. And now let's write, this in the domain. However, it may be easier if we drawed it on the number line and then write it in domain statement, stating where it is restricted at. They also use the set builder notation, so we can talk about that. Let's talk about the set builder notation. This here says I have a set that builds on x, where x is not equal to -3, and it's not equal to -1 or to +1. That's what that means, that set builder. However, now we need to write this in the domain terms. And whenever we're solving for the domain, it's basically we're looking for where the restrictions are at. So if I was to write this, let's draw it first. We have a -3, so I'm going to go ahead and plot that here. I got 0, I got +1, negative infinity to infinity. So this tells me that my x is going to approach that 3, but not include it, and it's going to be all the negative values. My x is going to approach that 1, and it could be values in between them. So if I wrote this in domain terms, I would say negative infinity, comma, -3, unions, -3 to 1, unions 1 to infinity. So this is just saying that we cannot have a -3 value for x, and we cannot have a negative or a +1 for x. If I did, I would get an undefined function here, and that's how they found it. Okay. So you can take a minute to pause this and read this. It's just telling you the domain, the set of function inputs found on the horizontal axis, the range, the set of functions outputs on the you're going to find on the vertical axis. Again, that's on the graph. Your y values on this vertical line, your x is on the horizontal line. So here it says, let's find the domain of this. Again, that's where you take what's inside this root. Okay, so what ago I said an even root. The even root, we can't yield a negative number on the inside. That's why this one will have a restriction, because if this would be an imaginary, However, if it was an odd root, you can have negative numbers, right? Because you can multiply something odd amount of times and come out negative if you have, negatives times negatives that odd amount of time. So this one here would not have restrictions, but the even roots would. And since we have a square root, we need to take what's inside it, set it greater than or equal to 0, solve for it. And when we do that, then I have this notation. Whoops. Well, let me go ahead and do it. This is what I was going to do. All right. So this tells me that x is greater than or equal to -4, meaning the equal to sign says we're going to include that -4. And since x is greater than, it's going to go off to infinity. Have y'all noticed that we always write the smaller number first in our interval notations? This is because we read left to right, bottom to top. Okay. So might take some practice. Thank you.